You guys hear me? Yeah? Okay, excellent. So the guy before lunch, so hopefully we can actually go quick here. So first of all, as a sustaining member of the iRODS consortium, I want to thank you guys spending 3 days with us, and certainly encourage you to collaborate more with the consortium at any level that you can. Certainly joining will be great as well. But you probably have seen from the presentations that people are doing great work. So we want to continue the collaboration. One of the things you probably think about is Seagate, yes, the hard drive guys. So what they really care about data management, yeah. Well, actually, data management is very important for us. I actually have the pleasure and the honor to work for Dave Fellinger during my tenure at DDN. So I got highly indoctrinated on data management by him and Dr. Moore on grids very early. So there's something that I have poured as my tenure now in Seagate. Storing data is very simple, and you'll see that what Seagate does is actually more than just unveil hard drives. Hopefully that comes out of our some of our presentation here. But it's actually the hardest part is to actually manage the data. And my responsibility is actually for healthcare and life sciences. So you can probably imagine that to traditionally, and I spend around 15 years of my life being a user on the healthcare life sciences side, data is highly distributed. And we talk a lot about genomics and importance of genomics and proteomics and what we do, from cancer research to predictive medicine. But really the value is not only on the research that's been done in genomics for a long time, but in the actual aggregation of the data from other modalities. Yeah, so having the ability to impact the pathway of a patient is very important. Bringing data not only the genomic side, but also on the pathology side, also on the radiology side. So hopefully you can see. I'm going to give you a little bit of a detail of what we have seen in years from my previous experience, and we can probably have some discussion about it. So let's try it that way. So one of the things that started large unstructured data sets, DICOM imaging. Yeah, so the whole discussion radiology and DICOM, and from the beginning this was a very problematic issue from a data management perspective, because you have a very distributed architecture. Several modalities didn't interact, in images wise. DICOM standard came together, and essentially now you can do vendor neutral archiving if you wish to do that, so you can actually at least aggregate those images. But one of the challenges that a lot of the hospitals have as an aggregation of those images is that they actually reside in different systems. Yeah, Casson system not necessarily similar to some of the other GE or ACFA systems. So no single data repository was actually a challenge. As VNA actually included into that. So if we add to that the ability to actually add other clinical detailed data to that, like lab data, like pathology data, or any other attributes to that patient, what you have essentially is a heavy load of HL7 interfaces. If you're not familiar with the healthcare environment, but think about it, you essentially have this huge conglomerate of interfaces that you're trying to aggregate data from one location to the other, try to normalize it, hopefully try to aggregate it to a single patient identifier. So a lot of challenges, and a lot of these networks are actually internally, so very, very small use of collaboration and the cloud at that point. Yeah. So they came in aggregation, and you probably have heard a lot about the EHRs, and what are some of the trends on data aggregation now closer to the clinic with electronic record management, in the healthcare side. But you still have the ability, you still have the problem that the data is actually disaggregated and in multiple sites. Yeah. So having the ability now to say, if I was in Canada, or actually let's take a US, so make it easier. If I was in California and I broke my knee, and then essentially, I came back to the East Coast, and I need to have a follow-up on that, having that data transfer not necessarily a simple play. Yeah? So the whole federation of those systems are really non-existent today. So in addition to that, we have other challenges today. So you probably have known, and we have a conversation with a lot of them, large instrument manufacturers as well. Everybody wants to measure you, yeah? So there's a lot of advantages of understanding your heart rate, what do you actually do on a daily basis, your sleeping habits and things like that, that could have essentially a potential input on treatment methods if you actually aggregate that data appropriately. Some of the data is actually aggregated specifically to measure if you have a condition, but some of it is actually, intrinsic data come from a Fitbit or any other connected device. So a lot of challenges, from a chain of trust perspective, from a security perspective, having the ability to aggregate that to other data on your medical record that actually make this like a single map of what you can do. And we talk about genomics, and genomics are important for a lot of reasons because it can help us predictively understand what could be some conditions that could affect you on the future. Yeah? So you probably have seen issues with breast cancer, for example, probably a lot of more the publicized ones, which certain variant calls on your genomic sequence can adhere that you have a susceptibility for it. But it goes a little bit deeper than that. Yeah. So and I have two very close cases of prostate cancer in my family. So my grandfather and my dad, and when my grandfather was diagnosed with prostate cancer, we didn't have the ability to actually understand genetically what could help him. Yeah. So essentially, doctors said, we're gonna cut you open, and we're gonna take things out. And essentially after that, if it continues, we'll try with chemotherapy. If that doesn't work, we'll try to radiotherapy. Now companies like Genomic Health, for example, have assays where we can actually tell you in a specific set of individuals with this specific characteristics, genomically, what will be the trend to be able to actually cure that cancer a lot more effectively without having to expose you to both treatments. Yeah. So having an understanding on the data and correlating that to genomics and to a set of individuals that have been treated for that specific cancer case, and in this instance, there are assays today that actually the insurance vendors, the third-party payers actually pay for, both in breast cancer, prostate, and colon cancer. So the whole idea, if you kind of think about what I'm trying to tell you is, the data is there, and we can correlate and actually make effective decisions that the physicians have not had that option before. So you'll see, and what we're trying to do as Seagate is making that a simple solution. Perhaps sometimes it's not that simple. So there are several of our OEM vendors or people that actually reuse our solutions that actually talk about HSM and data management. But clearly today, we see iRODS as kind of the potential, and there are several implementations that have proven that to be the effective way to aggregating these disparate data sets. Yeah. So hopefully that came out of what we do and out of the presentation. So just to give you a little bit picture, people know that we do more than hard drives. Yeah. So a lot of what we do is essentially scalable high-performance parallel file systems like Lustre and GPFS. We also have what we call a scale-out system architectures, which is essentially blueprints or scale-out architectures that we do on the object-based side, being Clever Safe, being Scality, being SwiftStack, OpenStack, or others. We're also the largest manufacturer of storage enclosures in the world, so we have a large OEM business, so we build enclosures and storage controllers for a lot of people. EMC, Dell, 3PAR, HP, down the list. And we also have a cloud service solution, which is a little bit different, which we actually have targeted to be essentially a compliant cloud service for being SOX and HIPAA compliant. So a lot of our financial customers or clinical customers can actually utilize as an extension of their system. So this is the cloud and system solutions part of Seagate, which is my part of the company. And the whole idea is to actually leverage all the building blocks that the company's building from a hard drive architecture perspective to all the enclosures and controllers, build up with a file system, and actually utilize a data management engine to be able to facilitate data transfer and collaboration on that. So hopefully you see on some of the drawings coming forward. And we do a lot of technology investments. We're a large research company, but the majority of the research we traditionally have done before I joined Seagate have been very close to the technologies that we sell. Yeah, so things about our acquisition of Abago and what we do on the flash controller side. Lowering the cost of the actual enclosure, increasing the density, facilitating management, stuff that you clearly see a storage vendor will do, but we did very little with data management in the past. So one of the things that we're trying to do, and if you see this from the mission of my group, that the healthcare and life sciences practice, is to actually facilitate to the researcher managing these workloads. Yeah, so can we actually do from ingest to archive in a single architecture? Yeah, you can see that. We'll show you some pictures of that. We can accelerate, your genomic workload by utilizing, a very scalable parallel file system. Yes, we do that. But doing all that is one piece of the equation. Yeah, having the ability, like I talked before, to actually integrate all those data sets and coming to a meaningful decision is a little bit more complicated than that. And making that simple for the physicians. Yeah. Majority of the research or clinicians are not data scientists or computer scientists. Yeah, I mean if you give them more than 2 passwords, 2 mount points, they'll look at you like what you're trying to do. So that's a very big challenge. And if we look at more science at scale, and some of the things that you're probably going to see, on the large computer iterations and what we've done with molecular modeling and things like that. The majority of this workflows are not done, they're not like in the old days where we actually built, an HPC cluster for one solution. So you're going to see that a lot of the research that we do incorporate, analysis and actually integrate in a converged architecture. So you're going to see from us we're working in some integration of iRODS actually intrinsic in some of our systems. So having it as a service that actually pertains. So when you actually buy a parallel file system, you have the option to say, check that as iRODS enable. So that's where we're trying to get from that perspective. So you'll see, hopefully that makes a little bit of sense. So the idea, like we talk about, is try to simplify the workflows. So if you take a look at, our vision from a object-based solution, and you probably have heard that, we actually manufacture Ethernet drives, which are actually, very object-friendly drives. So essentially, you can write directly to the object through an API, through the disk through an API. And several of the object vendors are utilizing that. But we're actually, you're going to see later on during the year, and we can have more discussion of this under NDA, working on a solution that actually consolidate workloads. Yeah, so you essentially have the ability to run intelligence on compression, on analytics, and everything on a single architecture. So we can talk about sanity of time. I'll answer that. But so we call that essentially an intelligent information architecture. And this data fabric will essentially give the researchers, from the acquisition of the data, being a sequencer, being a confocal microscope, being any type of lab instrument, to the actual process and analysis of it, to intelligent rules-based archive and management to the cloud if they distribute or collaborate with that. So what are we doing that? And one of the changes, going back to the genomics side that we have seen is, and we talked a little bit about this before, there's some data here, again, for the sanity of time. You can get a copy of this slides. My email address was the first page. I'll sign it again if you guys need to talk to me, thank me, or complain. You can definitely do that. But we have seen a huge shift, again, from research to clinical use of genomic data. Not only by the decrease of being able to actually acquire the data now from the instruments, which in the past, the majority of your cost was actually on reagents in the instruments. Now the infrastructure to manage the data and actually store the data is getting to the point that it's going around the same price or higher. So we definitely need to actually work on solutions that still operate at scale but provide an easier data management framework. In HPC is still important, yeah? So we still need, some large machines to be able to do these solutions, and the HIV capsid, is a good example of that. So we're going to run kind of real quick here for the sake of time. I want to make sure to make you guys to lunch quickly. But so this conversion infrastructure, this is one of the designs, give you a little bit of perspective what we do with some of our customers. And I'll talk a little bit about some of the points. In this reason is actually, sequencers, and don't think I'm talking only genomics here. Like I said, this could be confocal microscopes, and that example, it's just sequencers, any lab instrument, or any data acquisition device for the same reason. It could be, a radar or anything else. Doesn't necessarily need to be healthcare and life sciences. But a key component of this is how the data is actually managed between the systems. Because you can have a combination of a clinical system, a scalable parallel file system, some predictive analytics on it, or other type of data management as well. So we have picked, essentially iRODS as a, kind of a, box for a solution in saying where we can actually create a data grid that exposes the vision to the user that regardless what my data is it in an object side, if I'm doing predictive analytics on it, is it visualized, it doesn't really care from a user perspective. The challenge to that is security, and you probably have seen this slide before, actually from here, from UNC, where there are users that already are utilizing iRODS to actually do data management of clinical data and aggregation with genomics on a secure way. At the different scale, the majority of the users, still kind of a, distributed and a little bit complex way to manage. So we're trying to simplify this workloads to actually integrate it as part of the data path, if that makes sense to you guys. And we have also done in the past show where, we're talking about microservices and how the microservices are important, where you can actually even automate full pipelines, even from acquisition to the instrument, to the ability to actually process and align the data, to get, from BCL to FASTQ to BAM files, and even distribute the data appropriately. So having the ability to use microservices and actually work on this reference implementation for genomics is something that, in this slide, I actually steal from Dan. So you probably have seen that we're actually going to actively work on some of those processes, again, to make it, easier for the users. Challenges we also need to integrate with other things. Yes, I mean, we of course, as Seagate, build stuff for everybody, so Cray, SGI, and everybody else. So we need to deal with other HSM solutions. But I think the question came yesterday of like, what are my other options, if I use iRODS? Well, there are other options. There are other HSM solutions. I unfortunately, people that know me say I travel the world all the time. So I can tell you, the very large genomic institutes all over the world and the people that are actually utilizing this data scale, the majority of them are either utilizing iRODS today or they're considering doing that, because it would be great if somebody tomorrow said, I'm going to scratch every single piece of storage equipment that I have, and I'm only going to buy SGI equipment, I'm only going to buy Cray equipment, I'm only going to buy Seagate equipment or DDN equipment, or we build for everybody, so it's kind of mute point, but you kind of get the idea, yeah? So you need to exist and coexist with other data sets. So a lot of people say iRODS is the really way that I can actually expand that, collaborate with those data sets, collaborate with other people that perhaps have a different file system that I'm using to try to understand the same problem. Yeah? So that flexibility is key. But we need to integrate with other people. So I need to put the slide so you guys can see it. But the other part of this equation, I think I'm running out of time, is that iRODS also allows you to get the ability to intrinsically have predictive analytics running on some of these solutions. And if you're talking about not even using Hadoop, or what we do with what we call the Hadoop Workflow Accelerator, which is open source solution as well. We've got to give back to the community, but it's the idea to actually analyze data and size. So if you take a look at the ability, then if I ingest a large data set to a parallel file system, now I can also do the secondary analysis in that parallel file system. So my data movement, so although iRODS is actually managing that data, I want to control my data movement. Yeah, I don't want to push multiple sets of petabytes and data from one location to the other. So the more that I can do, when you saw the image initially, the more that I can create a system that allows me to do all the data manipulations that I have in a constrained environment, the better I am. So I got my 5 minutes warning. In the object side, and if I'm going to do collaboration to a secure cloud, the same thing. Yeah. So we talk about Scality is a good example of it. CleverSafe. So a lot of the object vendors will provide you a very viable solution for long-term archive and data preservation. You have seen our friends for CleverSafe join the consortium as well, because they really understand the value of what iRODS can actually play in an object-based solution. And we can talk a lot more detail on that. I think the big value that we also bring as a company is that we give you a single pane of glass to manage that. So when we build architectures like this, one of our core building blocks is that we will utilize a building block that is extensively for all these architectures. So I don't care if you run GPFS, Lustre, if you need to run an object-based solution, or you need to run iRODS or anything like that. We should give you a simple way to actually manage that whole continuum. So that's what we're doing as part of our management architecture. I'm going to stop there. Hopefully that makes sense, help you out. If you have any questions, and I think my email is there, so if you guys need to get a hold, I know the majority of you guys know me, but if you need to get a hold of me, we're always open for any questions.
So we do have time for questions.
I mean, that's what we concentrate on data management. Yes, data management is a key component of that. So the majority of the people that are doing, just take the example of genomics and proteomics because it's easy to everybody. Yeah, the majority of the problems that the large centers are running to is the length that it takes me from the time that I acquire the data to the time that I actually get a meaningful result. Really not only depends on where I run my data, sometimes depends that I'm moving my data for 3 or 4 different storage solutions. Yeah, so the actual physical data movement is a problem. But not only that, the ability to actually track, we talk about metadata is key here. Yeah, the ability for me to actually track where instrument that sample was run, to where it's associated, to what type of reagents are involved in that sample, because essentially it's a chemistry play. Yeah? So if I actually analyze samples in different, sequencers can be, different. So, but data management is really the main pain point that everybody's looking. Simple data management. Yeah. A lot of the other solutions, without mentioning names, HSM solutions are extremely complex to implement. Majority of them are very expensive. Yeah, because they're commercial solutions. So you probably have seen extensively that keep on pushing to iRODS to be a more, commercial robust solution for that. One of the reasons that we have invested in the consortium. So that's a key, need from a community perspective.
You showed a variety of healthcare, life science data. Genomic data, DICOM data for images, EHR for usual health records, and then now, of course, you have these data coming from patients in their everyday. Do you know of any system that is able to present a consolidated view of all of these? And if there isn't one, what do you think it'll take to make it happen?
I mean, that will make a lot of people extremely happy and I think very rich as well. The challenge is even so I have 15 years of experience in a large healthcare system, 70 hospitals. Yeah. Even at that level, when you have a single head that is actually managing multiple locations, you still cannot say, I'm going to guarantee you that every single one of my hospitals are going to run McKesson for HIS, or they're going to run Meditech. So no, I will say McKesson and Epic are probably two of the people that have more visionary about aggregating those data sets, but they're still closed systems, yeah? So if now I want to collaborate with another location, that's why you see like research hospitals like St. Jude's and some others, they really don't try to just join, a specific, because collaboration is key, yeah? And the ability to actually extract data out of those hospital information systems that really have been the aggregating point of the data is not a simple task. Yeah. So today,
even if it doesn't all come together, do you think a solution would be based on some sort of a federated model rather than everything going into one big pot sort of thing?
You probably want to answer some of that, yeah. Yeah.
I have no connection with this company, but we have looked into it, and they basically are doing just what you're asking about. And the company is SYAPS, SYAPSE, and they're under, so it's web-based, has a full API. You could do everything they do using their API. In other words, they drive their software from the same API that a developer can use. And I mean, I don't want to here to talk about SciAps, but it's worth looking into. Yeah.
Yeah, I mean, and you're going to see.
It's a graph. It's a graph database. So it does a lot of semantic inferencing.
Yeah, and graph analytics. So I mean, and you're going to see that the institutions that have more of a vision, like Hopkins and the Mayo Clinic and some others, have actually implemented some solutions that are more visionary than others. Yeah. Thanks. Hopefully that answers your question.
You mentioned iRODS-enabled storage, implying that when I buy the storage, I then automatically get an interoperability for data management.
So that's the goal, yeah. So if you are a user today, and some of us actually went to the training, and some of us have used iRODS in the past. If you drop a storage array at a hospital in a normal situation where you don't have people that are used to it, and you tell them, oh, iRODS is a good solution, install it and run it in there, they will say, well, that's great, and then we'll come to you and say, this is kind of hard, yeah. So the whole idea is that we're trying to enable our solutions to be iRODS ready. That means that, through an integrated way of actually installing through what we call some of our blueprints, or an integrated way that you can get an iRODS enabled solution. And there are some attributes of the parallel file systems, both in GPFS and in Lustre, now that allows you to do some of that connectivity. Still some work needs to be done there to make it more simpler and translucent to the user, but that's the goal, yeah. So you could have then a repository that becomes iRODS enabled from day one.
We'd like to thank our speaker.
Thank you.